Hi, I'm back for Unit 3 for the module from Chapter 7 of the textbook. So we're in Unit 3 of populations in our CED, but this is Chapter 7, and this is going to be Module 22 and 23, talking about human populations. So in the last two modules, we talked about certain things that had to do more with biological populations, kind of call it like that. And then now we're going to talk about the human population. And they give a nice case study here about China, which I'm not going to read, but you should take a look at this. They're talking about the environmental factors that are, affecting this population in terms of the increased middle class and the consumption of goods and how does this affect the presence of humans on this earth? That's kind of where they're headed with that. But we're going to talk about that during the module, so let's get moving. So human population numbers. Okay, so human population numbers. Scientists actually don't agree on the carrying capacity of Earth. Okay, so that's interesting. But we don't really know what the carrying capacity is of Earth. Every 5 days, the human population increases by roughly 1.3 million people. 2.1 million are born, and 800,000 die. Okay, so the population, if you look at it here, here's the numbers right here. So the population was very stable for extremely long time, you know. So you're talking about this is 2 million BC, 8,000 BC, all the way up to 1,000. And look at it, it's so stable. Really, you see that? But look at here. Here's the Black Plague. It went down, and then in the 1600s, with the advent of agriculture and then industrialization, the population has exploded, and look where it is now. How do we deal with that? The Earth was able to handle this, but is the Earth able to handle this? And how can we predict where we're going in the future? Are we constrained by any sort of limiting factors? What about food? What about land? What about all sorts of other things? So, we're going to talk about factors that drive human population growth. So, the factors that drive human population growth are changes in population size. So, we talk about the crude death rate, the crude birth rate, immigration, and emigration. And then we have fertility, the total fertility rate, which is the average number of children that each woman in a population will bear throughout childbearing years. This varies depending on if you're in a developed country or a developing country. And these are vocabulary terms that you need to learn. So the developed country is high levels of industrialization and income, and the developing country is low levels of industrialization and lower income. Rule of 70. How are we going to figure out how long it's going to take to double our population? So, the human population is a system. It's got all these variables happening. We have immigration and emigration, births and deaths. So those are inputs and outputs to our population. So we want to know the growth rate of a population. And how do we do that? So that's actually called its doubling time, which is how long it takes to double. So we use this rule of 70, and here's the equation. The equation is the doubling time in years is equal to 70 divided by the growth rate in a percentage. So the rule of 70 is a way for us to estimate the time it takes to double a number based on its growth rate. And in this case, we're looking at doubling the rate of the population. Okay, and here we need to learn immigration is the movement of people into a country. Emigration is the movement of people out of a country. CBR is the crude birth rate per 1,000 individuals a year, and crude death rate is the number of deaths per 1,000 individuals a year. Doubling time is the number it takes for a population to double. Total fertility rate is an estimate of the average number of children that each woman in a population will have during childbearing years. I had a sticky note on that. I don't know what happened to it. Okay, so let's move on. We talked about developed and developing countries. So here's average life expectancies around the world. So check this out. U.S. average is 78 years. And then the global average is 72. And then we have some areas of the world where we have below 50. That's life expectancy. So the life expectancy is the number of years an infant born in a particular country can be expected to live given the current average lifespan and death rate in that country. That's life expectancy. Infant and child mortality. So the availability of certain services like healthcare, good nutrition, exposure to pollution or toxins, pollutants, that affects mortality and infant mortality and child mortality. So the infant mortality rate is defined as the number of deaths of children under a year of age per 1,000 again. Anyway, so we're going to talk about, these are factors that drive the population growth, right? So infant and child mortality. Then we have aging and disease, obviously. If the population's growing and there's a high disease rate, this is going to drive the population growth. And then migration, which is immigration or emigration. So we talk about the net migration rate, which is the difference between immigration and emigration. Okay. So this is very important for the AP exam. You're going to need to know the approximate population sizes of the world and the 3 most populous countries. Oops, sorry, it wasn't on the video. I'm sorry. Know the approximate population sizes of the world and the 3 most populous countries. So we have China, India, and the U.S. are the 3 most populous countries. China has approximately 1.5 billion, India approximately 1.4 billion, and the U.S. is hovering just above 331 billion people. The world population is 7.8 billion people. You can read that here. This is all over here. Okay. I think I might have done that wrong. I'm going to check on that. Sorry. I don't know. We'll look at that. Anyway, so now we're going to go on to age structures. So calculating population growth is math, and it's a net migration rate, which is the number of immigrants a year divided by the number of people in the population, which is easy enough to do, and you come up with a percentage number. But okay, what is an age structure diagram, and how does that help us to understand population across an age range? So it's really good for us to know, because then we can predict what's going to happen in the future with that population. So for example, if you have a population that does not have a high birth rate, but their elderly population is large, you know that there's going to be a problem in the future because there's not enough people to support the population. And it could be the opposite is true too. So we're going to look at these. Let me just talk about, let me take this off. I'm going to talk about the specifics of the age structure diagrams. So the age structure diagrams are this. So you have to look at certain things. So on the left we have the male, on the right we have the female, and that's always the case. The y-axis is always up in the middle, which is kind of interesting, right? We've never seen a graph like that. And then you have your population size in millions. See, I think I wrote billions in that other one. I should have written millions. I'm really sorry. But anyway, we have our millions of population size going up this way, right? So, and I mean, going across this way. And then these are our ages in increments of 5. Okay. population size at the bottom. So there's different, if you just look at them holistically, don't look at them like exactly, but just look at the shapes of these. And let's talk about the shapes for a second. So in this one, we have something we call a population pyramid. It actually looks like a pyramid, right? And in this one, you can see that on the bottom of the pyramid, we have a very high population size of very young people from 0 to 10. Look at that. But moving up, you see that the population dwindles. So you see that there aren't people living a long time, and there's a lot of young people. So this is actually a Nigeria, and this is called a rapidly growing population. In the future, if these people live, this then becomes a little, these bars will come up here. But in this particular instance, we have a high mortality rate in that country. Okay, let's look at the United States. Look at this shape. This is more like a column, right? And then it just takes a nosedive off there, doesn't it? But here's the column, right? So we have a lot of people living into older ages here. So it looks like a column, right? So it's pretty stable, right? And that's the United States. So that's a column. That would be that there's an equal or approximately equal distribution of a population of people in the population throughout a wide variety of ages. Let's look down here at Germany. What's going on here with Germany? Let's look up at the 45, 50, 50, 55, 60 age and look how old how many people are in that age range. But look down here. Look how much it's changed. Okay, so when you see an age structure diagram like this, you know that this population is decreasing. So we had a big population growth here, but it's decreasing. And then over here we have China, and we can see that China had a huge population here, population size here. These people, now remember, we're down here because they lived. So these green bars were once down here. And now what's being replaced with is a much smaller population size. And this is because China has implemented population control strategies in their country to try to control the population. It does take some time for that to translate into the age structure diagrams. But there you can see it. Okay, so now you know how to read an age structure diagram, correct? There's also something that I need to mention, though, population momentum. So it's the continued population growth after growth reduction measures have been implemented. So this is, right here maybe is the momentum. So population growth is decreasing due to some measure that's been put into place. So that's called the momentum. We talked about the population pyramid. And that's it for Module 22. Answer questions 1, 2, and 5 here, and I will check them.